Okay, so today we're going to be going over Pysa, which is a ransomware gang that's been targeting government and educational institutions, mostly educational institutions in 2023. So today we're going to, simulate that attack and kind of show how that happens from this ransomware group. I'm going to be doing all the simulations on the left side of the screen here, and then kind of talking you through what the process looks like, and all the incidents are reported here on the right side of the screen. So here we can see the typical topology of a Pysa attack, which the first stage is executed using phishing campaigns. So they spread this via phishing campaigns initially. The network topology is composed of a firewall that filters and monitors internal and external network traffic from the local area network and externally from the internet. This firewall is monitored by Lumu here. So additionally, in this case, we have the endpoints that contain the Lumu agents that monitor network activity in a hybrid and home office setup. Unfortunately, this example doesn't have very good security policies, and it exposes their 3389 port, the RDP port, remote desktop port without any VPN or SDP requirement in place there. So it's common in these ransomware campaigns they use to spread phishing, again, as the initial vector. That's the point of entry typically. They're targeting, financial or administrative teams, these educational organizations, because they usually don't have enough cybersecurity education or good security practices or policies in place. So that's generally the target. So they save a lot of also sensitive information, right? Information that's going to be beneficial for the attacker to compromise. So here on the left side, we have an endpoint. It's a common endpoint that the command here in the domain controller, and it's going to be a financial role in this demo example. The host name is T Simpson, as we can see here. So that's the host name here. T Simpson. That's finance is the name. And the IP address here. So this one is, let's see, 172.16.166.132. So that is the IP address there, and that's what we're going to be looking for when we see things in the Lumu portal. So we're going to simulate what this experience looks like. So what happens is that an employee receives a phishing email, right? And this is typically what it looks like. So in that phishing email, it looks like maybe something like a monthly report that they typically receive. It has a monthly office supply receipt. So it has all the information, looks fairly legitimate. And the employee ends up, downloading this. And you can see the values here in that button, the download receipt, the XLS document. And actually with that one file, they download the Excel document. It's trying to really simulate the downloading of an Excel document. The victim downloads it. And we see here the receipts.xls, but really that's a malicious document. So after the victim opens it here, thinking this is a normal Excel document, it's very common for the attackers to insert images. So you can see here that this is the document. Again, it looks very realistic. It's very common, again, for attackers to try and make this look more realistic, put some images or graphics to try and deceive the victim and start that infection chain. So in this case, after the victim clicks here, the open button, the document installs a payload of Quackbot. That is a malware that uses a .chm file there, which is a helper file used in the Windows systems. But now it's going to execute further steps until the malware payload is installed there. So the malware is detected by Lumu in two sequences. You're going to see two separate instances in the portal around this. The first one is when the payload is downloaded in the background. So when that initial download takes place, that marks the initial contact with the malicious infrastructure. And second is going to be when the crackbot command control starts to send or recollect the stolen data. So those are the two separate incidents that we're going to see in the Lumu portal. In this example, we have company corp here, the incident labels. Okay, now we see the two incidents here, the two Quackbot incidents. The first one is the download process. So let's click here and see what the IOC, a little description of malware there as well. And the part of the detections or incident activity, as well as the collector that detected that action. And in this case, it's passed through, but that's for demo purposes only. Let's just show you how this attack is carried out without those responses in place. And then the destination here to download the Quackbot binary there. And second, you have the other incident, which is the command and control step here with the IOC, also Quackbot family. So you can see here all of the threat intelligence related to this IOC, Quackbot, the different names and the same malware family, related families, as well as more information about the threat family in general. So the information about the detection, the same firewall collection and the endpoint IP, all of that information is here in the incident. So the Quackbot was detected by Lumu, and now this endpoint is infected, and all the credentials, email, and financial accounts, and more connections, sensitive data is going to be stolen at this point once that attack is starting to take place on the simulation on the left. Unfortunately, the dark market has a lot of vendors of this type of information and ransomware gangs that are associated with them to use all this credential in the cyber kill chains or cyber attacks. All right, so here in the second stage, the attacker used the RDP credential stolen in the last pass, and the last step is to connect to the compromised endpoint. So the attacker can now connect it with this T Simpson endpoint that we've been using. And now with the machine in control, the attacker really is able to scan the entire network using a typical living off the land technique. The attacker downloads a legitimate program for network administration called Advanced Port Scanner. And additionally, this program, it doesn't need to be installed. So we can see here in the temporary location how the attack is stored to binaries, right? So the Advanced Port Scanner with the graphical interface and the Advanced Port Scanner, an Advanced Port Scanner console. And actually that's what is going to be used. So let's enter this location, the APP data, and we're also going to enter, all right, APP data here. I'm going to follow these, local tab. And lastly, advanced port. So now in this location, the attacker performs the command. So here we can see an advanced port scanner console. And in this situation here, we're going to scan in from the IP. So we're going to scan 1 through 50. So 50 endpoints. Now we're scanning the internal network here. So we're scanning the internal network here. I'm going to give it another second. We're performing basically a network scan with the information that we have here. Now, okay, because the firewall and NetFlow logs are redirected to the virtual appliance, Lumu is able to detect the malicious scan and alert about this behavior as an incident. So let's go in the portal, refresh. So now when that scanning takes place, you can see under incidents, there's a network scan incident here from the IP that is ending in 132 that we've been using there for the example. So that's what produced that network scanning incident, those commands that we just completed on the left. So here we can see the source, the IP, the description, network scanning, and all affected assets or endpoints. You can see all of that, visualize that here, and everything that was related to the incident. So all the different endpoints there. We can export all of that to a CSV file to be able to have that information directly from the Lumu portal there. So now after this stage, the attacker has identified the sensitive endpoints or servers, including domain controllers or other servers in the same network segment. So after that, the attacker tries to move laterally. That's very common, to then move laterally once you've gained that access. So to do this, a common precursor in ransomware attacks is the use of mimikatz. And this is really a malicious tool that is really well known in the cybersecurity world. Used to dump credential hashes stored at in the cache. So the attacker basically downloads that mimikatz binary from malicious infrastructure using another living off the land technique like what we saw. So they avoid the firewall and the IDS or IPS detections, anything like that. This attack is designed to bypass those detections. So the attacker in this case is using basically a shared binary originally intended for secure certificate validation. But in this case, the attacker used the URL cache and split and downloaded the file really and saved it and stored it in a temporary location. So let's see here. So just for the simulation, we could see the command prompt. This usually is something that's done, of course, in the background, but we have it. And so let's show it and show what that command prompt looks like. Okay, so we're online. And now we can see here the incident where the attacker tries to connect with the malicious infrastructure and download that mimikatz binary there. All right, 1 second. Okay, here we have it. All right, so now we have the incident reflected here, and we can see that the IOC actually has the same URL that you see there. And here we have another family that it's mimikatz related, but when we consult the threat intel information, let's see the mimikatz here. Yeah, it's a same threat family, the Windows 64 or Win64, but it is associated with that mimikatz binary that we were talking about earlier. So here we have all the information about it. You can see additional threat intelligence, and we have some hashes that you can insert into different platforms, for example, EDRs, IDS, or IPS if you want. All right, so finally, what's going to happen now is the attacker is going to dump the password hashes from the else's memory. So unfortunately, we couldn't have access to the admin credentials. For example, a network administrator that is present in several devices on the network. So with these credentials, now the domain controller is also compromised, and the Pysa attacker really can spread to the final step of the infection with that control. So we can see now how the attacker executes some binaries here to automate the infection process of the domain controller, and it's detected by Lumu. It's not reflected here on the left side because we don't have access to the domain controller, but we can detect it via the Lumu portal. So just a moment here, just a second. All right, here we have the new incident. So it's an incident related with the Pysa ransomware family. Now that we've reached that final sort of step there. So it was detected when the attacker tried to connect their malicious infrastructure to download or run the command and control action. So basically, it's detected by Lumu here that is in fact the domain controller, and that was detected by the Lumu Windows agent, as you can see there. So we can see how the process was detected. It's update.exe, and it's a common binary that is used by the Pysa ransomware gang, and the local addresses for the domain controller as well that we have here that ends with 129. So now we're sure that the DC school here in this example is compromised, right? So as a final step, the attacker usually uses DNS tunneling to exfiltrate some, configurations from here. So that is the database server. The attacker is also, compromising the domain controller. So some endpoints and now the database server. So they're going to use that DNS tunneling to exfiltrate some configurations from the database to maybe create persistence in the network in case the encryption routine fails, and they'll try to use it and enter it again after the attack. So in this process, sensitive information is encoded into the subdomains or the host fields and the domain name, and is sent using the DNS system, basically. All right. So now we're going to take a look at the Lumu portal, and we're going to show how these types of DNS instances are detected there. Now, there's going to be another section of the portal, the intelligence section. We're going to go to analytics from there. And from there, we're going to look at we have two sections there, really. We have this anomaly section that you're looking at here, and you have the DGA and you have the tunneling. So here we can see how the DNS transfer site in the server is sending information using those subdomains and host fields in the DNS name. So the attacker is sending information using the DNS system. And that's how you visualize that in a Lumu portal. So this was the final step. Now the attacker has completed their attack process and has encrypted the selected files. Depending on the company's security environment, that data could be exfiltrated to any cloud provider. In this specific example, you can see how the encryption process was really carried out from beginning to end. So that is our Pysa attack simulation. Thank you very much.